Testing, testing, testing. Hey, good morning, folks. Let me transition over. Good morning. Let's see here. Yep, we're good. Always got to check yourself, make sure the mic is working. How we doing, folks? Hope we're doing well. Got a few people up and on here. Today is going to be a rainy, crummy day. Really windy. So, good day to hang out inside. Haha. Joke for the day. Not really. No, it's a pretty dreary day. Hopefully it clears up pretty soon so that we can get back outside a little bit and get some of that nice sun. In terms of today, what we're doing is going to be really short. It's just module 48. It is pollution control measures, and then next time we meet, which will be on Wednesday, will be the final two modules for the content that we really have to cover from the textbook that we haven't talked about yet. So we'll get to the point where if we want to go over something, maybe start doing, I guess, like kind of like review sessions like this, something like that. Yeah. That'll be something we'll talk about. But today we're going to do this, and then if you want to talk about the FRQ that is due today, there was one that was posted out. It's due tonight, I think, at 11:59 p.m. So if you want to hop into office hours, talk about that, whatever, I'll be open to do that. Again, my office hours are for you guys, 12 to 12:45. You can get the link in the Google Classroom. I always get those two confused. So, anyway. Here we go. Pollution control measures. So, after reading this module, you should be able to explain strategies and techniques for controlling sulfur dioxide, nitrogen oxides, and particulate matter. All the stuff that we mentioned last time is involved with the creation of smog, which is definitely not something that you want around you for, breathing. Or just growing things. I mean, it's a pretty bad thing to be breathing in. It's not good for your health. Blocks out the sunlight. Not great. And this module also has you describing innovative pollution and control measures to combat those specific things. So, pollution control includes prevention, technology, and innovation. Ways to address air pollution? Well, to start off, if you can just avoid it, that makes it a lot easier to clean. So if you are going to be using cleaner fuel, right? We talked about the different kinds of coal and how some have more sulfur and some have less right there. Just something through the stages that they develop to having more or less. So using specifically coal that has a lower content would certainly be reducing the amount in the first place. Increase the efficiency of what you're burning so you don't need to burn as much. That definitely will help to reduce overall air pollution. And then control the pollutants after combustion. We'll see that a lot of the ways that we're looking at deal with this part, right? Where you are going to go through burning your coal, burning your fossil fuels, whatever they are. They're going to control the pollution after you've done that. So these are all the different ways that you can address it. It's easiest and the least costly to avoid it in the upfront cost, right? In the first place, but that's not always reasonable, right? You just have to burn coal. You have to burn fossil fuels at some point. So, ways of controlling emissions. Here are a list of all the different ways that you can do so, and I have a whole bunch of diagrams to outline it a little bit better, as well as there are a few videos that you can watch to help you as well. So the first way is removing sulfur dioxide from coal by something called fluidized bed combustion. Now I do have a video of this showing exactly what fluidized bed combustion kind of looks like, but essentially the idea is, and I'll kind of go between the slides, you've got coal and you have limestone that is kind of mixed in with it, and you are going to be fluidizing the air. What that means is you're going to be putting these two particulates in the bottom of this chamber, but you're going to be shooting air through it. What that does is it makes it act like almost like boiling water, where it's churning, it's got like bubbles of these two things mixing, combining, and mixing the limestone with the coal actually helps to capture some of the sulfur dioxide that would be there. So you're adding the limestone. It's written in the textbook specifically as calcium carbonate. They're the same thing, right? Limestone is made of calcium carbonate. So you're bringing these two things, you're like tossing them together at the bottom as you're burning them, and then they capture, as they usually do, that energy through water, which makes steam. Steam turns to turbine. Turbine turns to generator. Generator makes electricity. So the whole point of doing this, again, is to get that limestone mixed in with the coal so that you don't have the same sulfur emissions. Also, this is just a more efficient process as well, and you can use other things as coal because it's more efficient. So that's also kind of a neat fact. The next part is catalytic converters on cars. So on a car, you have your exhaust system. You have this little box, and let me get to it. You have this little metal piece that's part of the exhaust underneath the body. And this part right here is designed to take some of the products of combustion and to make it so that the things that come out are not as dangerous. So what you have is inside of this thing is a honeycomb. It looks like this. It's like this grid pattern where air is going through the catalytic converter, and you have different rare earth metals, different things that are going to cause reactions to happen. So as it's going through, it takes some of the dangerous things that we don't like. For instance, you've got NOx, you've got carbon monoxide, and you have hydrocarbons, which you also don't really want to breathe. Also oxygen that comes through that's left over that wasn't fully combusted. But these are the things that you start with, and as it goes through this metal honeycomb with all these interesting rare metals that cause these different things to react and go from like carbon monoxide to here you've got the NOx and the carbon monoxide turning into atmospheric nitrogen and carbon dioxide, much better, right? Atmospheric nitrogen is around us, and carbon dioxide is, again, a natural thing. Or you could have the hydrocarbons, the carbon monoxide and oxygen going through a reaction where you get water and carbon dioxide. So again, you've got like these different kind of things going on inside the converter itself based on what's there and the different things that line those different channels. And the end product is things that are a lot more environmentally friendly and human healthy, right? Carbon dioxide, if we breathe it, it's not a terrible thing versus like carbon monoxide, which is not so good for us. So definitely useful thing. It reduces smog by a lot. And if you watch a video that I have listed, although I will say, fair warning, there is a little cuss at the beginning of it, but the science is really good. So if you skip past like the first minute or so, it's a good video. So next one is a baghouse filter. So what is that? This is primarily looking at getting rid of particulates that would be from the coal burning or whatnot. So this would be after you have it burning, after the heat is captured, you would send the air that's left over that's moving in this system through one of these bags. The dusty air would have it come through and up, and air would go out of this. It's a porous bag. It's got space for the air to go through, but not the particulate matter. So it traps the dust on the inner surface of the bag, and then it filters it out, just like any other kind of like air filter would be doing. So that's the idea here, is that you've got it going through this this bag, trapping all the dust, and then the air would be getting pushed out so that it was not sending all this particulate matter out into the atmosphere. Do we need to memorize these? Well, because it's an open book test, no, you don't. You have the textbook. You have all sorts of things at your fingertips. So it's good to understand how they work and why people are using them. The idea that, they want to control particulates because particulate matter, breathing that in, as we mentioned last time, right? If it's really, really, really small particulate matter and it gets in your lungs, it can clog it all up, get into specific parts where gas exchange is happening. So definitely something you want to avoid. And also it blocks out the sun, leads to smog, a whole bunch of bad things. So just understanding why, they're using these different things. Because again, it's open book, so. All right, use electrostatic precipitators. This also is going to combat particulates. So what they do here is they've got incoming gas with the particulates. You can see it waving in, and it goes through these charged metal rods, and then later these charged metal plates. So they charge the particles with these thin rods. It goes through the plates, and because they've negatively charged the particles and the plates are positively charged, it ends up making them come together. You've played with magnets before, right? The opposites attract, so all of the particles get stuck to these plates, they clean them off, and then they keep going. And that is going to have the gas that leaves totally particulate free. So another cool way that they can get that going. Ooh, sorry. Clean up your air. And then lastly, scrubbers. So this is directly in your textbook. This has to do with using these water jets with the dirty air, and it acts like a way to just knock all of the particulates out of the air and down to the bottom. So let's read through it and get through it that way. So number 1, dirty air enters the scrubber. So you've got over here at the bottom, it's going to come up through this part of the ventilation. Number 2, combustion exhaust steam moves upward in shower of water mist. So again, these right here, this is a water channel that's making all these little, if there's a fire or something in a building, all those little sprayers go off, similar to that, right, where it's just shooting in a cone. It shoots down, the mist collects those particles, or in other words, scrubs them, brings them down to the bottom of the unit. That's 3. Then you've got 4, dirty water moves to a sludge removal system, so it all comes down, goes through tubes, and gets disposed of. That's 5. 6, the water moves back to the scrubber for reuse, so they're not overusing the water here. It's not clean, fresh water every time. They're reusing the same water every time. Number 7, excess mist collects on screen, so they have something else to catch anything that would going upwards, and then cleaner air exits through the stack. So if you didn't do this, all the particulates would just be going up and into the atmosphere. Here they're using water to knock it out of the air, collect it, and then continuously scrub the air with that water. So this was the video I said that does have a little bit of foul language, so go at your own risk, but I have to say it's a really, really well explained video. It's a shame that it does have that. So if you want to skip that, skip past I think it's 1:30, but he goes into exactly all the different little reactions that are going on inside the catalytic converter, so take a look at that at your own risk. And then this was another video that talks about that fluidized bed combustion, where they're having that limestone and also pumping air through so that it contains it and is more efficient. All right, so around the world, people are implementing innovative pollution control measures. Municipalities have tried a number of strategies, including reducing gasoline spilled at the pump, which gets rid of the VOCs in the air, as well as some other things right from the evaporating fluid. Reduce the use of wood-burning stoves and fireplaces. Those also are going to have VOCs, as well as some nitrogen oxides and carbon monoxide too, since it's not a complete combustion usually for wood. So that definitely has a whole bunch of other things that you don't really want, so they've been reducing the use of those wood-burning stoves. And then limiting automobiles to every other day use, or charge user fees for roads during heavy commute times. That we don't really do so much here, but definitely in China they've got plates for the different days that you're allowed to be using your car. They've got some of those restrictions in other places in the world too. But certainly trying to combat every little specific thing you can in small ways to try and overall help the amount of pollution that is actually getting released. That's the idea. So every little thing you do, right, less gasoline at the pump, if you can limit the number of cars, definitely going to help overall. And that was it. That's it for today, guys. Short little 15-minute notes. We'll cover the other parts. What is that? 49 with ozone depletion, and then indoor air pollution. We'll be doing that on Wednesday. If you guys want to, again, hop into office hours later today, 12 to 12:45, the link will be in Google Classroom. But that's really it for this little module, and then we'll get going on Wednesday. If you have any questions, let me know. But yeah, that's pretty much it. Oh wow, this lighting looks terrible. Nobody even mentioned it. I look so red. Why? How are we going to have a test on this? That is an excellent question. Wow, I really need to change this in terms of the lights. Let's see here. So in terms of testing, testing is something that we can talk about in office hours when we get back. We will talk about how everything's working. We're kind of figuring out what our strategy is going forward with grading and whatnot. We have ideas, but we have to kind of see when we're actually coming back to implement or not implement them. If we do come back to school, things will kind of go back to the normal progression of all the different types of grades you're getting, but I'm not sure exactly what we're doing right now officially, given circumstances. So I don't want to say anything here right yet. We could talk about it in office hours if you want, but right now just worry about the content, worry about practicing FRQs, get ready for the AP exam. That's the big thing that you guys need to be concerned with, and the class grades will be something, we'll handle down the road. So, any other questions, folks? All right, folks. Well, if you have any other questions, come to office hours. You can always email me too. Make sure that you do the FRQ that was posted on Google Classroom, and I'll be looking over those, giving you some feedback tomorrow. Adios.